Okay, so I welcome you all to the DDR demo session. Okay, so this is DDR demo session of batch 2, where in this demo session, it is meant for the DDR course of the batch 2, where we are focusing on the DDR3 and DDR4, uh, uh, DDR3 and DDR4 versions of the DRAMs. And myself, Amit. So I am working in a product-based company, and I have 7 years of experience. And currently, also in my company, I'm working on a DDR project. And so I'm a resource person here in this LO chip, and the LO chip is constantly providing the protocol knowledge and the protocol training to the uh, tech enthusiasts or the working professionals. Okay, and currently also we are providing the next ongoing coming uh, 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 in Elopship, we have so many programs. So one of them is a DDR, and coming we are preparing for the PCI and the AXI and APB things are AMBA protocols. Actually, we are giving from past 3 years, and this is the second batch of the DDR. Okay, and if I can proceed next. Okay, so I want to ask you some questions before proceeding to the next topics. Okay, so the today's sessions will be going to something like this. The session topics are like a introduction. Okay, so which is just ended. So next I'm going to give the basic knowledge and the market trends of the DDR. Okay, and the demands of the DDR, and what are the needs, and what are the trends are going on in the market regarding the DDR and regarding the jobs and all. Okay, and these are the things I'm going to give next. After that, we are going to look for the course motive, and from the LOPCHIP, we are conducting this course, right? So what is the motive behind it? Okay, why we are doing this? So those kind of things. And after that, we are going to see the course content. So what I'm going to deliver throughout this course. Okay, that will be coming under the course contents, and after that, the course outcomes will be, and what are the course after the course you are going to get from this course. Okay, so what are the outcomes of this course? And finally, we are going to take some queries from your side. I'm going to take queries from your side, and you can ask any questions. So be prepared. If you have any queries, please keep a note. Okay, keep a note, and in between in the session, if you get any questions in between in the session, if you get any questions or queries in between in the question, any queries you get, so please note it down and please ask me in the end. Okay, so if you get urgent query, so you can just interrupt me, no problem. Okay, okay. So what I'm going to do first here is, so let me ask you some questions. So there are 22 members in the meeting, so I want to ask everyone a question. How many of your people, how many of you know about the DDR? And how many of you don't know anything about the DDR? Everyone. So you can just put it in the chat. Okay. So how many of you know the DDR, and how many of you don't know anything about the DDR? Yes. Please put it in the chat so that we can see. Okay. Lakshman, Kirpal, Nikhil, no. Madhu, I have a basic idea about. Okay. Pradeep, no. Okay. Niranjan, no. Okay. Ashutosh, no. Okay. 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 So, okay. Iqbal, no. Kuldeep, okay, no. No. So basic idea only. Okay. Okay. Ashutosh, Manjunath, okay, no. Okay. So, okay. What I can see here is most of them you don't have knowledge about the DDR, correct? And you want to learn the DDR from the scratch. Yes. And some of you people have the basics knowledge about the basic knowledge of the DDR, and I think when I talk with someone, so they are currently working in the like a HBM's things actually. So HBM is nothing but a DDR, the advanced versions. Okay, so they are working on HBMs, but still they want to learn the DDR from the scratch. But these are the kind of the scenarios we have from your side. So So based on this only, we are going to start the courses, like what most people are asking. So based on that only, we design our courses. Okay. So previous batch, what we handled, so there also nobody had the knowledge about the DDR. Nobody had the any kind of experience on the DDR. So from that kind of student, from that kind of scenarios, we designed the course last batch, and we successfully uh, completed that course also. And now this is the second batch. Okay, so we are going to start from the scratch only. And because most of them, you don't have any knowledge on the DDR, and most of the people want to learn the DDR. Okay, yes. So if I can start from the beginning, so from the scratch. Okay, so I ask myself a question first. So most of the main heading is the DDR, correct? So what is mean by? Okay, what is mean by DDR? What is mean by DDR? Anybody? Anybody in the chat? Yes. Anybody in the chat?
Double,
What is
double data rate.
double data?
Samples on both edges, negative percentage.
Okay. Okay. What else?
Double data rate. RAM.
Okay. What about then I'll ask one more question. Then what is mean by DRAM?
Dynamic RAM.
Yes. Then if you see anywhere in the online, so if I search here, DDR DRAM, I'll search. Not only DDR, not only DDR, I'll search for DDR DRAMs. Am I right? Am I right? For example, I'll search for some of the laptops here, laptops. Okay. In the laptops, it will directly take me to the Amazons. Okay, I'll go to the Amazon. So in this Amazon one, so they are mentioning here 16 GB RAM, 16 GB RAM. And what is this RAM? 16 GB RAM, DDR RAM. Am I right? 16 GB DDR RAM. Also, in this 16 GB DDR RAM, they are again, here it is a DDR5 4800 megahertz. This is 16 GB RAM. This is again 4 GB DDR4 RAM. This is 8 GB DDR4 RAM, random access memory. Okay, DRAM it is, nothing but DRAM. Okay. Why they are mentioning DDR and again along with the RAM? Why they are mentioning RAM along with the DDR? Anybody? Why they are mentioning it a RAM along with the DRAM?
Like it's when we consider RAM, so again it comes into the picture like a data rate or transfer speed of data transfer. So if we mention DDR, so as we know, like data transfer could be speed while accessing the data from the RAM. So that's what like my perception or understanding. But
Okay.
could be
If you
other
are talking about
also.
the speed, if you're talking about the speed, they are also mentioned that. They also mentioned that. Okay. So if I go to here, you can see DDR. Okay, here it is. Okay, frequency 2400T, correct? And 4800 megahertz, correct? And if they are mentioning it 2606T, these are the transfer rates. These are the transfer rates. We can call it. So Utsav gave an answer here. So DDR is a technology on which DRAM is working. Okay, if you had gone through my previous demo session, so in that I explained DDR is nothing but double data rate. Everyone know that DDR is nothing but double data rate. Then what is this double data rate? Yes, I know that every POSIX and NEGGET, every POSIX and NEGGET, I am sending the data to the DRAM from the controller. Every passage of the clock and negate of the clock, I am sending the data to the DRAM from the controller. This is the DRAM. Correct? This is the double data rate. In a one cycle, I am sending 2 times data. In one cycle, I am sending 2 times data. That is correct. That's correct. If I show it to you, if I show that in your like this one, just a minute. Okay, if I show that in the diagrammatically, if I have this clock, correct? This is the positives, this is the negatives, this is the positives, this is the negatives. This is one clock, correct? This is one clock. At the positives of clock, I am sending the data, and again in the negatives of clock, I am sending the data. So this is data 1 and this is data 2. So this becomes DDR, double data rate. Am I right? So this is then attached with it, we have one more which is called DRAM. DRAM is nothing but a collection of memory elements. Collection of memory elements. Collection of memory elements. So in the DRAM we have two types. So one is SRAM, one is DRAM. We will see the differences between this SRAM versus DRAM in the next class. In the coming classes, we are going to see the differences between SRAM and DRAM. Don't have to worry about that. But in specifically, we are looking at the DRAM here. In specifically, we are looking at the DRAM. So the DRAM is nothing but the collection of the memory elements here. The collection of the memory elements, which is arranged in a array format, which is arranged in a like a arrays in a block. In this block, we are arranging the memory element in a array format, which are called DRAM. DRAM. So there is architectures. There are architectures. I'm not going to depth of architectures now. I'm just saying DRAM is nothing but a collection of arrays, collection of memory elements, in which we are going to store the data, in which we are going to store the data. At what rate? At a DDR. At a DDR. At a double data rate. At a double data rate, we are going to do the write operation and the read operation from this particular memory elements present in that DRAM, which is collection of the memory elements. Understanding? So this is the main basic thing everyone should understand. So the DDR is nothing but a technology. Okay, DDR is nothing but a technology, and DRAM is nothing but a collection of memory elements. Combining both of them, it will become DDR DRAM. Can we send? Can we do the SDR here? SDR. What is meant by SDR? Anybody? What is meant by SDR?
Single data.
Single
Not
data
neither
rate.
positive.
Yes, at one passage of clock or negatives of clock, any one in a one clock cycle, at a passage of clock or any negatives of clock, I am going to send the data. I'm going to do the any write operation or read operation. Is it possible in the DRAM? Anyone? Is it possible in the DRAM? Anyone? Is it possible? In the DRAM, can I do that?
I think we can do, but the speed is slow.
Yes. So the previously it was there before the evolution of this DRAM. So there comes the before coming to the DDR. So there was SDR. Okay. So the DDR is evolution of this SDR. Inventing this SDR, they moved next to the DDR. Why? To increase the data rate. Initially they were using the SDR. After that, they directly moved it to the DDR to increase the efficiency, to increase the bandwidth, okay, to increase the speed. So they moved to the DDR. Now in this DDR, we have different versions. So what are those versions? Anybody? What are those versions? Again, in the DDR, we have versions. So the DDR, again, DDR, in the DDR, they first invented this DDR1. Again, they came and they invented DDR2. Again, they came and they enhanced some features and added some features and invented DDR3. And again, in this DDR4. And again, the DDR5. And again, it will evolve and it will become DDR6. Again, DDR6s are there. The LP DDR6 are there. So I'll come to this point later. LPDDR, what are those? Okay. So these are the evolutions happened. What are these evolutions? Why it is happened? Why it is happened? Why it has happened? So already we had the DDR. Why needed the DDR2? So the reason is every evolution, they did some of the changes in the every versions of. For example, if I go in depth of this now, okay, this will take a lot of time. So what I'll do is, so I'll give a just one example. So I'll give a just example. In the DDR1, the frequency of this was very slow. Okay, if I talk about the frequency, okay, the DDR1's frequency is greater than less than DDR2. Okay, the DDR2's frequency was less than DDR3, and DDR3's frequency was less than DDR4, and DDR4's frequency was less than DDR5, and DDR5's frequency was less than DDR6. Understanding the point. Understanding the point. So if I talk about the frequency, this is how this increases. So every DDR technology, they increased the frequency. The minimum frequency and maximum frequency is there. In every DDR, they have the minimum frequency and maximum frequency. In every DDR versions. In every DDR version. Okay. I'm taking one example. That's it. I'm taking one example how they evolved. I am taking one example like this. So how they evolved? This is how they evolved. Okay, so we have a separate session on this. What are the differences between all these DDR versions? What are the changes are there in DDR1? What are the changes are there in DDR2? What are the changes are there in DDR3? What are the changes are there in DDR4? What are the changes are there in DDR5? What are the changes are there in DDR6? Comparing to the previous versions. Okay, if I can take one more example, in the DDR3 we don't have bank groups. But in DDR4 onwards, we have bank groups. Correct? In the DDR3, we don't have bank groups, but in the DDR4 onwards, we have the bank groups in it. Until DDR3, we don't have any bank groups in the architecture. Only we have is banks. Don't worry about that. Don't worry about that. I'm just taking one example and I'm just telling you what are the differences, what kind of differences we have. If you again take one example, comparing to the DDR3, in the DDR4, they reduced the power consumption. Comparing to the DDR4, they reduced the power consumption in this DDR5 because so in this it was consuming 1.2 volts and it was consuming 1.5 volts. Understanding the point. So these kind of the evolutions evolutions happened in every version of the DDRs and they evolved like this. Now you understood. Okay. Now you understood. What are the how the DDR is there? What is the DDR? What are the DRAMs are there? Okay. What are the DRAMs are there? Then why should you why you need to learn this? This is my main question next. Why you should learn this? Yes, DDR is there. Okay. Okay. Someone is telling, okay, market is going very mad about it. Okay, DDR is going very mad, like evolving. This is booming now. This technology is booming, and we have to learn it. Whoever they're in the VLSI industry, so they have to learn it. Correct, correct. Then I'll ask you one question now. Everyone. I'll ask you one question now. Okay, how many of you think mobiles and laptops uses the DDR only? How many of you think what percentage of the DRAMs are used by mobiles and laptops in all of the manufacture? For example, in 100 DRAMs are manufactured. For 100 DRAMs are manufactured, how many DRAMs are used for mobile and laptops? Okay, Narasimha Reddy. Okay, 15%. What about others? Others? Iqbal, Ashutosh, Kulashekar, Devnath, Neeraj, Abhishek, Narasimha. Yes. So you can just put it in the
Question is
chat.
the
Yes.
question
You
is
can
like
just
what percentage DRAM are used in the
yeah.
laptops and
Yes,
mobiles?
yes, yes, yes. For every 100 DRAMs are manufactured, how many of those are used in the mobiles and laptops? You know already, right? So every kind of
Mm,
mobiles have the DRAMs, every kind of the laptops have the DRAMs. Correct. Correct.
mm, mm.
Correct. Now, what percentage of those manufactured DRAMs are used in the mobiles and laptops, and what percent is not used in 100%?
No, 100% in the sense like every device has to has a. I mean, like laptops and mobiles should have a DRAM, right? So uh, out of 100, like all must be used. I mean, like all in the sense not 100 DRAMs in
Okay.
the on the same. So
Okay.
like uh, could be like dispersed and used.
Okay. So, so you are saying so most of them are used for the laptops and mobiles. Am I right?
Yeah, yeah,
Okay.
could. Yep.
So, yeah. And Utsav Sharma is saying maybe 30 to 40%. Okay. And Ashutosh approximately 50%. Uh, without, yeah, Pankaj is saying without memory, nothing is possible. Yeah, obviously, nothing is possible. And Mohote Iqbal is saying 80% of the like in 100 manufactured DRAMs, 80 DRAMs are used for mobiles and laptops. Iqbal is saying, okay. What if I say you? What if I say you? Around 30 to 40% of the manufactured DRAMs are used only for the mobiles and laptops. Only for the mobiles and laptops. Then what about that 70 to 60%? What about that 70 to 60%? In every 100 manufactured DRAMs, only 30 DRAMs are used. I'm not talking about any other things. Only DRAMs I'm talking about. DRAMs, DRAMs. That can be any type. That can be any DRAM type, DDR type or DDR3, DDR4. I don't care. But I am telling about only the DRAMs. In 100 manufactured DRAMs, only 30 to 40 DRAMs are used for mobiles and laptops. And what about others? What about like a 60 to 70 DRAMs? Where they gone?
Like
Anybody?
by the time like manufactured, so while using, so they may have a bugs or like they are not working properly.
Okay. So let's take it as
Nowadays,
an ideal example only. Let's take
Huh.
we don't have any bugs. We don't have any like wastage in that. We don't have any
Okay.
waste DRAMs in that. In that case,
Mhm.
every 100 manufactured DRAMs are there, and every DRAMs are ideal only. In that case,
Okay. So the
so I
question
can
is like where the rest of the DRAMs are used
rest of are
apart from
going.
the
Yes, yes,
laptops and mobiles.
yes,
Mm.
yes. If I can answer this, if I can answer this.
Huh.
Except this 30 to 40 DRAMs, except this 30 to 40 DRAMs, everything are going into different domains. For example, what are those domains? What are those domains? Those domains may be here I can write. Those domains may be one is automobile. Am I right? And one more thing is consumer electronics. Again, consumer electronics, inside the consumer electronics only mobile only come. Okay, I'll accept I'll take the this mobile exception for the mobiles. Okay, what are the other consumer electronics? Consumer electronics are what? Nothing but smartwatches, smartwatches. Okay, smart wearables.
Smartwatches, TVs.
Yes, TVs, fridges,
Yeah.
fridges, washing machines.
ACs.
Okay, yes, ACs. What else you can? What else examples you can give? ACs, ACs we had. Okay, what else?
AirPods.
Yes, the smart variables it will come. The smart
Yeah.
variables. Okay. Okay. It's- So, other than this, what are the other than this? We can use the DRAMs in. We can use the DRAMs in server machines, right? server machines, right?
Yep.
In the AI PCs, in the AI PCs, in the graphic cards, am I right? In the server
Yep.
machines we can use. What is the difference between the server machines and what is the difference between our normal laptops? What is the difference between these server machines? What is the difference between these server machines? For example, I'll search. Okay. So normal, okay, normal, whatever the PCs we have in our homes, we have the desktops. Before laptops, we had a desktop, correct? Correct. In some companies also, they use desktops for home. Okay. So desktops for home, I searched and in the Amazon, I can get those desktops. So these are kind of the desktops. Okay. I can get it for some 21,000. So these kind of things. Okay. The 16 GB and 512 GB and 16 GB of RAM is there. Okay. In this, I can see, okay, this 256, the SSD is there and in this 8 GB RAM is there. I can get it for only 12,000. If I search for the server PCs, if I search for the server PCs, okay, if I search for the server PCs, can you see the difference here? Can you see the difference here? So the Dell, this is the server PC, which will be, you can see in your companies, which you can see in your companies, the server room will be there. In this server rooms, so server PCs will be there, which are for 2,89,000. This have the 64 GB of DDR4 RAM, which has 40 cores. Understanding? So in our normal desktops, it may have a single core. It may have a single core or dual core maximum. But if you come to the server PCs, it may have like a 50 cores, 100 cores. Okay. So you can see the rate difference also here because these server PCs are meant for high performances, high computations. Understanding the point? Understanding the point. For example, AWS is there. For example, AWS is there. Where the AWS is hosting the hosting the servers. In your companies only, I'll take the example. In your companies only, I'll take the example here. Okay. In your companies, if your company is hosting some application, for example, your VCS tools or any cluster sim tools or cadence tools are hosting in your company PCs, correct? So in the server rooms, okay, in the server rooms, you have server PCs here, server PCs. Okay, these are nothing but a CPUs which are running the applications inside it. The Linux application is running in it. Correct. The n number of Linux applications are running inside it. Correct. So you are the user here. You are the user here. Okay, you are using the cadence tool and you are accessing that. Correct. Now for this server PC, you have the RAMs attached to it. So different RAMs are there and different GPUs are there. Different GPUs are there. So using this only your normal processing unit, which are the processors are working. Correct? 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 Now, for these kind of applications, do you need only 8 GB of RAM? No. If you apply the 8 GB of RAM, it won't work. It won't even process the normal basic applications. If you are running the two Linux applications, so it will be done. The maximum load will be given to this processor and the processor will die. Now, what kind of the RAMs you need? More number of. In our normal laptops, in our more normal laptops or normal desktops, home desktops, the maximum you can use is 32 GB. 32 GB. That too for the personal use. That too for the personal use. But inside these kind of the server PCs, the minimum you should have is 64 GB. It may extend to 512 GB. It may extend to 1 TB. This is not, I'm not talking about the SSD. I'm talking about the DRAMs. I'm talking about the DRAMs. I'm talking about the DRAMs. This is the capacity of the DRAMs present in the server PCs. If these kind of server PCs, these kind of DRAMs are producing, these kind of DRAMs are manufactured for the servers. Okay. So you can imagine what is the kind of the demand for their, are there for the DRAMs. Correct? Correct? In the same server PCs, in the same server PCs. For example, I can take it as a Facebook server room. I can take it as a Facebook server room. Inside this Facebook server room, they are training some AI models. They are training some AI models. On which computers they will train the AI models? On their laptops? No, they have a server room for it, and they have hosted some of the CPUs for it. Server CPUs, server PCs are there in their server room, okay, which have these kind of specifications for the DRAMs, and they are training the AI models in it. They are training AI models in it. Okay, if they are training the AI models in this kind of applications, you can imagine what kind of data they are using, how much data they are using, and how much data they are training into their models, and what is the computation they needed. Correct? They need more capacity GPUs there. They need more capacity RAMs there. They need more capacity of DDRs there. Correct? Correct. DDR DRAMs there. Then you can imagine the AI is increasing now. The AI is increasing now. Correct? The AI is increasing now. The AI era. Similarly, the AI training will be going to increase. If the AI training is going to increase, then obviously the server PCs consumed will be increasing. If the server PCs are consumed will be increasing, then the manufacturing of the DRAMs, the manufacturing of the DDRs, obviously going to increase. Correct? 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 So that is the kind of the demand we have. If I can show you also, every companies, for example, Cadence I can take Cadence DDR. Okay, so you see the Cadence DDR is also producing the VIPs. Why? For the manufacturing, for the production, they are producing the IPs, VIPs. For the verification purpose, they are producing the VIPs. For the manufacturing purpose, they are producing the IPs. Not only Cadence, I can take the Synopsys. I can take the Synopsys DDR. Yes, this is also producing the IPs, IP solutions. And if I take the SK Hynix, one of the top player in the DDR manufacturers. Okay, SK Hynix DDR. Yes, these are the main players. SK Hynix is the main player which is playing in the DDRs. Okay, if I take the Realtek DDR. Yes, it is also taking the DDR. It is also taking the DDR part. The Realtek company, which is meant for the Bluetooth and Wi-Fi, but it is also playing the DDR. They are also working on the DDRs. If I again take Dell DDR, yes, they have the manufacturing again. Correct? They have the manufacturing again. So these kind of every company. So if I take the one more example, Qualcomm DDR. The Qualcomm DDR, again, the Qualcomm is working on the DDRs. Am I right? Am I right? So these kind of the demands we have for the DDR nowadays. If you learn this DDR, okay, I'm sure that you are going to get a great opportunity in the market. You are going to get the great opportunity in the market and a great designation in your institution or in your company. I'm sure, because this is the uh, in demand tech which is needed for every individual who is working in the VLSI. If he is in the front end, no matter if he is in the front end, if he is in the back end, doesn't matter. He need to learn the DDR, because this is the kind of the demand we have in the market. Okay, so already we are getting some updates like a DDR6 is coming up, DDR6 is coming up. Yet this spec is not available yet, but the work is going on, and by the end of the 2026 we are going to get the DDR6. Okay, this is the kind of the news we have. But already the so many companies are taking up on their DDRs. Okay, so many companies are working on the DDRs. So many companies are adopting the DDRs in their SOCs. In every company, every SOC is working, so they are including the DDRs. Why? If I can take the example, if your washing machine is there, smart smart washing machine. Yes, this is a smart washing machine. Inside this, there is a small Linux application going on. Inside every smart application, inside every smart washing machine. There is a smart Linux applications is going on, which is running some codes, which is running some automation. On how it works, they need a minimum RAMs. You can't imagine an application or a Linux application or the small computers running without RAM. It is not possible. Even in the small kind of Arduinos, you can attach the RAMs. Correct. So already you have the some kind of KB in size of the KB. You already have the RAMs in the Arduinos also. Arduino is nothing but if you are aware of the Arduino, so those are kind of small pieces, small kind of pieces, the tinkering species, you can say. Correct. This is the kind of the DDR demands we have in the current market. If you are going to learn this, if you are going to learn this technology, I'm sure that you are going to get a great opportunity in your companies or in your organization. Okay. Okay. This is the kind of the demands we have. Got it? Anybody have any queries in that? I'm going to move to the next part actually. Yes.
Yeah, Amit, what we understood is DDR. We thought initially DDR consumers are majorly mobile phone and laptops, but we got to know around 30 to 40% our manufacture mobile phone laptops manufacturers depends on DDR, but major DDR dependencies for all company servers and this website. Whenever we need to launch the websites, so that will consume, and like as you mentioned, like electronics consumers also medical applications and satellite and military applications, like that means everywhere which all are case some codes or some linux are running, so those all needed DRAM you are seeing. So due to that our mobile phone laptops consumers are less compared to other applications. So yeah, till this point.
Yes.
Yeah.
Yes. Yes. And you can also see that in the coming days. So every mobile or every small devices are going to get the AI models running in that. If you see your watch, the AI model is running in your watches, smart watches. Okay. If you see a small AC or a small refrigerator, that is running on a AI. If you see a IoT device, if you see Alexa, if you see a Google Assistants, there is a AI thing is which is going on. If you see headphones, in that headphones there is again the ANC is there, adaptive ANC, on which it is working. It is working on some of the earphones are working on ANC on AI things only. Correct. If you don't know ANC, so ANC is nothing but adaptive noise cancellation. Okay. So those kind of things which is working on AI again. Every small devices are getting the AI. If you are getting the AI, you need a more computation there. If you need the more computation, the capacity of your DRAM should be great there. You should increase the capacity of the DRAM. Then only those kind of AI models will run efficiently in that. Okay. Now, my next question is, okay, we understood. Okay, we understood.
So, Amit,
Every kind of
due to that only nowadays all companies they are starting their own DDR teams, right?
yes. As I explained, so every kind of companies are getting involved into DDRs. Every kind of companies. If you see the Cadence, Synopsys, and SK Hynix, Realtek, and Dell, Qualcomm, every kind of companies they are working on the DRAMs. If I can take again some more examples, ST Microelectronics. So again they are working on the DDRs. If I can search DDR again here, so this is working on the DDRs again. Understanding. So every kind of FPGA, whoever producing the FPGA, whoever producing the SOCs, whoever producing the IPs, so they are all working on the DDRs because this is very in demand, very in demand in the future due to the AI also. The AI is taking the more like a part in this. Got it. Got it. Now, so if I can proceed further, okay. If I proceed further. Now we got to know, okay, every small devices. I listed some of the applications here. Okay, automobiles are there, consumer electronics are there, server machines are there. And if I take again examples as Chandan was saying, so the medical devices, and again the satellites, okay, and again the automobiles I took, okay, and again the IoT devices, Okay, IoT devices. Okay, okay, understood. So these kind of the applications we have, but do we use only the DDR in this? In every kind of applications, do we use the DDRs? Yes. Double data rate we use. Double data rate we use. Do we only have the DDR technology? Do we have any other alternatives for this DDR? We get a question, right? Okay, we are using the DDRs in every other automobiles. Okay, consumer electronics, server machines, medical devices, AI PC, satellites, graphics. Okay, okay, so many other. Do we use only DDR? Okay, I can take a DDR X. X is nothing but the versions of it, 1 or 2 or 3 or 4 like this. Okay. Do we use only DDRs in this? Anybody have any idea? Depending on the different application, depending on the different applications, we have to change the technology. Okay, technology. Okay. Then what kind of the different technology in the DDR we have? What kind of the different technologies of the DDR we have in this? And what are those applications of it? In which conditions we have to use them? If I can list them, so one we have is DDR. Already we got to know DDRX. I can write it like this. And one more we have is LPDDR. LPDDRX. Again the LPDDR. Again the DDRX. How we have 1, 2, 3, 4. Similarly in LPDDR. Don't worry about the LPDDR. LP. What is this LP? We don't want that. Only focus on the DDR now. Yes, we have the DDR. Again, this is one technology and this is another technology. But what is this LP? We'll explain this. And what is the application of it? Yes, we can get to know this in the future. But I'm just listing the technologies we have. Again, in the LPDDR we have, which is the version we have is 1, 2, 3, 4, 5. And again, the 6 we have in this. And again, the 5 we have in this. Correct? And again, if I take one more example, so the GDDR we have. The GDDR. This is again one more technology. Again, we have
HBM we have.
HBMs. Yes. Sorry?
Yes, HBM we have high bandwidth memory.
Yes, yes, yes. HBMs also we have. So again, in the GDDRs, we have the technologies like 1, 2, 3, 4. Correct? In the HBMs, we have 1, 2, and 3. So the HBM 3 is the maximum, as per my knowledge. Okay? Okay. Then what are these? What are these? We got to know, okay, the double data rate. It is the double data rate. Okay. Okay. We can apply this in the PCs, laptops, correct? Laptops, correct? And again, mobiles, I said. Do we apply the same DDR in that? Do we apply? So if you can see here, I searched for one DRAM here. I searched for one DRAM here. Shall we apply can we apply this kind of a DDR inside our mobile phones? You can see
So,
the mobile phone is not this much big also. How can we fit this kind of DRAMs inside our mobile phones? It is not possible. Then what kind of DDRs are used in the mobile phones then? This is the question we get, right? This is the kind of the questions we get now. This is the kind of the questions we get. Correct? Correct? Now, no. Sorry for that. Again, I'll write. So we have the DDR, we have the DDR, and okay, we have the DDR, we have the LPDDR, okay, and we have GDDR, and one more is HBM. Now, what are the different applications of it? Now, I'll tell you the application. Based on that, you should tell me what is the difference between this DDR and LPDDR. Now, I'll focus on the LPDDR and DDR, and you should tell me what is the difference between this DDR and LPDDR. For example, I'll give you one example. The DDR can be used in laptops. The DDR can be used in laptops. The LPDDR can be only used in small devices. The small devices are nothing but the medical devices. I can use this. The mobile phones, I can use this. Why? Why can't I use the DDR inside mobile phones? Why can't I use the DDRs in the medical devices? Why can't I use the DDRs in the satellites? The satellites can use the LPDDRs. It can't use the DDRs.
According to power consumption, sir.
Yes, yes. That is the main reason. That is the main reason. The
Low
LP,
low
whatever
power.
they mentioned here, yes, this suggests me that this is the low power. This is the low power DDR, which consumes the less power to do the DDR double data rate work, which consumes the less power comparing to the DDR again. Comparing to the DDR. Again, you can see the DDR, we have 1, 2, 3, 4, 5. Correct? I said from the DDR4, they are going to consume 1.2 volts. In this, they are consuming 1.1 volts. But comparing to these also, the LPDDR is going to may consume. I'm not saying consume, may consume less power than the DDRs. Again, this depends on the LPDDR versions. Which version is that? Again, it is whether it is a LPDDR1, LPDDR2, LPDDR3, depending on that, we can say that. Correct? But these kind of the low powers are used in the mobile phones and the medical devices. Not only the power consumption, I'm saying, not only the power consumption. Inside this DDR, I can say one thing. I can say one example. I can say one example. In the DDR, we have one feature. We have one feature which is low power mode. Low power mode, which is low power mode. We have to push this into a low power mode. We have to push this into a low power mode. But in LPDDRs, it may go to the low power modes automatically whenever the work is not there. But inside this DDR, we have to push it from the controller. Only pushes it. Controller have to detect it and push it. Then only it will go to the low power modes. But in the LPDDRs, this feature is altered. This feature is altered and implemented so that it can consume the less power. It can consume the less power and it might go to the low power states. This is the one feature I'm saying. What is this low power state? We will look at it. We'll in the coming future classes we will look at it. You can imagine, right? What is the low power? Low power is which consumes the less power to do the work. Whenever you put the laptops on sleep, it will go into the low power mode. But in the medical device or the mobile phones or the satellites, it have to detect more faster than the DDRs and it have to go to the low power modes. Correct? So this is the difference between the DDR and low power LPDDRs. Then what is this GDDR? Anybody? What is this GDDR then?
So
Yes, we understood DDR.
for gaming laptop and all, we are using GDDR.
Okay. Gaming laptops and all, we can use the GDDRs. But in the okay, I'll search for it. I'll search for it. Okay, gaming laptops, RAMs, gaming laptops. Okay. So if I search for the gaming laptops here, in the gaming laptops, again, I have the 24 GB RAM is there, 1 TB SSD is there. Okay. But how can, again, we have the 24 GB RAM only, right here? Again, you can see the another laptop, 16 GB RAM is there, 512 GB SSD is there. Okay. So here also I can see this is okay, 8 GB LPDDR5 is there. Okay, the laptop is also using LPDDR5. Okay, and here in this laptop 16 GB DDR5 is there. Correct, correct. Then what is the difference between this? You can see this example I can take. This example is a good example. See here, the Lenovo. This is the gaming laptop only. Okay, in this we have the 24 GB RAM and 512 GB SSD. Apart from this, we have the NVIDIA RTX 3050A 4 GB. What is this again? What is this again? In this gaming laptop only, we have the DRAM, correct? 24 GB DRAM we have.
So
And
in
apart from
GPU,
this, we also have the NVIDIA, yes, RTX 3050A 4 GB, this one, GPU.
so in GPU part we
Then
are
what is
using.
this? Yes,
Other than that,
yes, continue. Yes, someone was selling something, right?
so I'm saying in GPU we are using in crypto miners are there, and some servers also
Okay,
we are using.
okay, okay. So these kind of the applications we can use the GDDs, correct? If I
Ye-
can elaborate it properly, explain it properly. So the GDDRs are used in the graphic cards. GDDRs used in the graphic cards, not as a normal ordinary RAMs. These are the ordinary RAMs. Whatever you are seeing here, right? The 24 GB RAM is there. What is this 24 GB RAM? This 24 GB is nothing but, okay, RAM is nothing but, you can see these kind of the RAMs you will get, 24 GB RAM. These are the normal kind of the RAMs. These are the normal kind of the RAMs. Then if I search for the GPU RAMs, GDDRs, if I search for the GDDRs, you can see the GDDRs are present inside the graphic cards. The GDDRs are present inside the graphic cards, not as a normal ordinary RAMs, not as a normal ordinary RAMs. The GDDRs are present inside the graphic cards. So whatever you are seeing here, this is the graphic card. This is the whole graphic card. This is the PCI ports. These are the PCI ports. Okay, this is the graphic input output, and this is the PCI ports. And inside this, we have a processor. Inside this graphic card also, we have a processor. Around this processor, we have the RAMs. We have the RAM cards here. Not RAM cards. These are the modules, RAM modules. What are this? These are GDDRs. You can see this is the NVIDIA RTX 600 ADA. Correct? Inside this, we have a processor. Around this processor, we have a RAMs. What kind of RAMs are this? What kind of a DRAMs are this? These are the GDDRs. These are the GDDRs. Now we get a question. This is the processor. In normal computers also, we have a similar kind of processor. And why do we have the GDDRs, sir? Why can't we have a DRAMs here, DDR here? Why don't we have a DDRs here? Why do we have only GDDRs here? Anybody? Anybody? Anybody?
Hello.
Yes? Yes.
Sir, because the high bandwidth data.
Sorry? Hello? Am I audible?
Yes, yes, you are audible, Amit. I think this is Pankaj issue.
Okay. Okay.
Hello, am I audible?
Yes, Pankaj. Yeah, you are not audible. Yeah, you can tell.
Yeah, sir. I am saying for
Pankaj, I think you have some network issues, I guess. So please check a connection, and if possible, please rejoin the class, because the network is not stable there from your side. Okay, no problem. Yeah. So other than Pankaj, anybody? Anybody can tell me, why do we have the GDDRs here? Why don't we have the DDRs here? The normal question, right? The normal question also I get here. Why can't I use the LPDDRs? Because LPDDRs, it can consume the less power. If it can consume the less power, the graphic card consume the less power. If the graphic card is consuming the less power, the power consumption will be less there. Overall power consumption will be less. So that I can use the graphic card in a less power. That is a great thing, right? But in specifically, we are using the GDDRs here. Why? That is my question.
It should access data continuously.
Sorry, sorry.
Data need to access continuously in graphic cards.
Okay, so in the DDRs also we can use the data continuously. Am I right?
sir, am I audible?
Yes, Pankaj. Yeah.
Sir, actually, GDDR is designed for like maximum data bandwidth. Their power, like the goal is different. Like we don't want the power efficiency. We want maximum bandwidth there. So that's why we go
Yes,
for the GDDR.
yes.
And
So,
sir,
but
for GDDR, like in GPUs, we have different the cooling system and all. So that will maintain the we don't have the possibility of power efficiency.
Yes, yes, yes. See, one thing I can say you here is why we need the LPDDRs? We need the LPDDRs because we have the constraints there. The LPDDRs are compact. These LPDDRs are compact. Why compact? Because it should be compact because it should be fitted into the mobile phones. It should be
Yeah.
fitted into the medical devices. It should be fitted into the satellites. Why? It should be small enough to fit into the mobile phones, satellites, and medical devices, which are
Yes, sir.
small.
It will work on
Correct?
battery.
Yes, battery also, and it should consume very less power so that we can get the maximum efficiency out of it. Correct? Correct. So in this case, we don't have any constraints, such constraints. We have the only constraint here, which is we should get we should get maximum bandwidth. We should get the maximum bandwidth here. We don't have the size constraints. We don't have the power constraints here. Whatever the size you can use, yes, you can use. Whatever the maximum power consumption, yeah, you can use. But again, there is a limit for it. There is a limit for it. I'm not telling you can use, you can create a box, a big box out of, no. You have some constraint for it, but you can use, you can extend it. We don't have any problem with it. But what we want a maximum bandwidth in this. You know how the graphic cards works? You know how the graphic cards works? So whenever you transfer some data into it, it is connected to the another PC. Another PC is nothing but your motherboard. If you are connecting this to your desktop or your laptop, you are connecting it using a PCI port to the main processor. If you have a 4 Intel i5, so those kind of processor, you are connecting it to the PCI port, and from the PCI port, you are connecting this NVIDIA RTX or any kind of GPUs. What happens there? Whenever you read or write the data, that write or read data will come and it will sit into this GDDRs first, not directly go into the processors. Not directly go into the processors. It will come and it will first write into this DRAMs, not sorry, the GDDRs. Now, inside this, we have a small computers here, small processor here. So what this processor will do? This processor will read from this GDDRs. These processors will read from this DRAMs and it will process and it will send back to the main processor. Understand? Understand? Now, this processor only have the task. What task it is? To compute, to compute the zeros and ones. It don't have any kind of any other processors. In the normal PCs, in the normal laptop processors, in the normal desktop processors, you have many other tasks, correct? You have to handle the many other tasks. But in this, what do you have? You have only one task, which is to compute. The incoming data is there. Depending on this ALU, you have to compute it. That's it. Whatever the data present here, you have to read it, compute it, and just write it back, and it will the main processor will read it from this GTDS. Okay, that's it. You don't have any other work here. That is the reason these processors are very data hungry machines. Okay, okay, these are very data hungry, where it needs more number of data to compute per second than the normal processors. So that is the reason you need more bandwidth here for this. The input bandwidth for this is more. Now, how will you compensate that? Using this GDDRs. Again, why can't we put the DDRs here? Because the DDRs don't have that much capacity to put that much bandwidth here. But the DDRs have, GDDRs have. GDDRs will work more parallelly than the DDRs. That is the reason the GDDRs will read and write the data from this processor more parallelly, and it will put the data and it will read back the data more parallelly and more in a more sufficient efficiently. And the bandwidth of this GDDRs are more here. Understand? Understand? That is the reason the GDDRs are used inside this kind of graphic cards. Got it? Point. The GDDRs are used in graphic cards. So again, in the further classes, we have the more discussions on it. More discussions on it. Like what are the different kinds of LPDDRs are there? What are the different kinds of the GDDRs are? What are those features? What is the features are different between the GDDR 1, 2, 3, and what are the applications of it? Correct? And the last one we have here, which is HBMs. Which is HBMs. What are the HBMs? Anybody tell? What are the HBMs? What are the HBMs? Anybody tell me what are the HBMs?
It is high bandwidth memory.
Okay. These HBMs are nothing but high bandwidth memories. Now, what is the difference between HBMs and DDRs? Okay, we have the DDR, LPDDR, GDDR. Then what is the difference between these HBMs? Why we are hearing the weird name here? High bandwidth memories. What are these? Anybody have any idea? Anybody have any idea on this?
So for servers and all, we are using this
Okay.
where the bandwidth and or more high for AI for data centers, sir, we can say.
Okay.
Yeah. So it is, I think, sir,
Basically,
so DDR only. They are just connected two DDR together, as per my knowledge.
actually, we can't say in that manner, but because what happens is, so okay, I'll explain. So this HBMs, you can see the difference. We don't have the DDR name in it. So in the LPDDR again we have the DDR. In the GDDR again we have the DDR. Again, we don't have the DDR name repeated in this HBMs. In the HBMs we have the different name itself. The high bandwidth memories are this. Correct? Why are they given the high bandwidth memory? Because comparing to the, obviously everyone can get to know, okay, DDRs in LPDDRs, GDDRs, more than this, we can get the more bandwidth from these HBMs. At the same time, these HBMs are very costly, and require more precision, to manufacture. Anybody tell me why we need this kind of precision for this to manufacture? Why should I need this kind of precision for this manufacture, HBMs? I said we need more precision. Yes. Anybody have any idea regarding the DDR? Anybody have the architecture knowledge of the DDR? Anybody? Yes. Why? I'll tell you. In a simple word, if I can say, in a simple words. Comparing to the DDRs, it can be any DDR, it can be any version. Comparing to the DDRs, DDR have a 2D models, 2D architecture. What is this 2D architecture? 2D architecture is nothing but if I have this DDR memory array, this is the memory array. In this memory array, I have the memory elements like this. In the columns and in the rows, I have the memory arrays. Correct? In the columns and in the rows, we have the memory arrays. This is the 2D array. This is x-axis. This is the y-axis and this is the x-axis. Correct? But if I compare this with HBMs are not like this. This is one memory array, right? One memory array. In HBMs, how they are made? These are made like this. If I have this one memory array, this is one memory array again. Okay, this is one memory array. I am stacking these 2D memory in a I'm stacking the number of 2D arrays in a stack like this. I'm stacking this. If I stack these number of 2D array memories, so this will become the HBM now. So in this axis, you also have in the inner side, correct? in the inner side. And in this x-axis also you have, in this y-axis also you have, in this z-axis also you have. In this z-axis also you have. Just think like that. In this 2D array you have, right? In this 2D array you have, right? You are having number of 2D arrays here. Number of 2D arrays here. You are stacking it. You are stacking it. Correct? You are now have in this kind of manner. In the x-axis also, in the y-axis also, and in the z-axis also. Now, combining this like this, it will make an architecture, HBM architectures, the memory array architectures. Now, whenever you are trying to access a memory element in this to write or read allocation, this is the different. Now, whenever you are accessing a small memory element or the memory read or write location in this is different. That is the reason this technology is a slight different from the DDRs. This HBM technology is slightly different from the DDRs, but this is very efficient. This is very efficient because you can get the more bandwidth in this. But as I said, this requires very high precision for the manufacturing. That is the reason these are very costly. Very costly. Okay. Okay. Now, can we use these kind of the HBMs in the normal consumer electronics? No. Can we use this kind of HBMs in the normal this kind of gaming laptops? Can we use this kind of gaming inside the gaming laptops? Can we use? No, we can't use. I'll show you one example here. I'll search for HBMs. I'll search for HBMs here. Okay. I'll search for HBMs. I'll go to the images. Okay. So here you can see, here you can see, this is the processor. This is the processor. This is the processor. Around this processor, you have DDR5 here. These are the DDR5s. And you can see there is a processor. Around it, you have the HBMs. But can you compare the number of HBMs present here and can you compare the number of DDRs present here? That is very significantly less amount of HBMs are there around the processor. Why? Because it can put the that much bandwidth. It can give that much bandwidth for the processor so that we only need 4 HBMs are sufficient here. I'm taking this as a hypothetical example. I'm not taking this as a technical. Around this processor, again, we have this many number of DDR5s. Why? Because we need this much processors, this much bandwidth we need, this much DDRs are needed for this. You can compare for the same capacity, we need only 4 HBMs, but we need this many DDR5s around this. Why? Why? Because the HBMs produce more bandwidths again. Okay, again. We can't use them in a normal server computers also. We need a very high-end computers. I'll search here. Server PCs with HBMs. Server PCs with HBMs. You can see the Intel Xenon Max server series processors can feature high bandwidth memories. You can see. So these kind of the server PCs are there which can use the HBMs. Again, you have the different features there. If I can tell you one example, you can't use in the DDRs. We have one feature which is training, retraining and write training. Before using it normally, before doing it a read or write, whenever your PC boots up, we need to train this DRAM to do the work normally. But in HBMs, we don't have that. Why? If you're consuming more time in this training, how can you make the efficient use of this HBM, correct? So that is the reason. Inside this, whenever you are using the HBMs, you don't have to train them. Again, they are trained. You have to directly plug and play. If you are using the DDR, no. If you are plugging it, you have to give some time to it to adjust to that PC, and then it will work normally. Understanding? So these kind of the features are differentiated between DDRs and HBMs. Got it? Got it, everyone? So that is the reason HBMs are very high, like a costly, very costly. So we can't use them. Got it? Anybody have any doubts on this?
Means Amit, you are saying training means, for example, in our laptop, we replace one DRAM and we place the DRAM to in our laptop. So first we need to reboot our laptop. So that time it will take training things.
Yes, 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 yes. So for example, if I am running this laptop, correct? If I'm running this laptop, for example, in this laptop, I have a DRAM. I have a DRAM. I have a DRAM. So for example, also I'll open and show you. So this is the application called RAM on. In this application, you can see which DDR it is connected to your computer. So in this, you can see the DDR which is connected for this my laptop is now DDR4, which is running at a 1600 megahertz. Okay, DDR4 3200. 3200 is nothing but a mega transfers per second. It is mentioned here. The maximum bandwidth it can produce is 25,600 Mbps. Correct, correct. This is the number specifications I have for my laptop. The DDR4 3200 is installed in my laptop. Now I want to change this to DDR4 to DDR5. DDR4 to DDR5. Okay, my laptop supports that. My laptop controller is there. It can support the DDR5. Now, what I want to do, I'll just replace this DDR4 and I'll install the DDR5. Immediately after installing, it will not work. It will not work. What I have to do? I have to restart my laptop. Why? Why I have to restart my laptop? Because every time, whenever your DRAM is inserted, whenever you turn on the PC, at that time, the controller will adjust itself for the DRAMs, or DRAM will train itself for the processor to work properly, to sync with the processor. The timing parameters are there. You will get to know all these things. I'm telling the one example.
Sir, I think
So that time what happened? Yes, yes,
sir, I think after every power off, it will do the training part.
yes, yes, yes.
It is not if we
So that's
change.
what.
If it is off also, same DDR4 will train after a power off.
Sorry, I can't understand.
Like sir, if we off the PC every time when it will boot,
Hmm.
it will do the training part.
So that's what I told, right? So whenever you change, so for example, I remove this DDR4 and I put the
No, sir,
DDR5.
I am saying if we won't remove also, it will do the training part.
Like you see, whenever you put the DDR, then only it will train that DDR, correct? Whenever you put the DDR, then it will train that DDR. So in the booting time, correct? So you can't change this in the middle of the process. You can't change the DDR in the middle of the process. Whenever you put that at the time of the booting, it will train that DDR. Correct. So that's what I was telling in the simple words, actually, if I'm not wrong. Yes. Yes. Correct, right? So someone was telling. Forgot. Like I didn't say.
I think Pankaj is saying like, sir, if you don't replace our laptop memory also, then whenever we switch it off our laptop, automatically that our laptop every time. For example, if we inside, for example, our laptop DRAM is there. Whenever I switch it off my laptop, every time that will do the training part. So Amit, every time it will do, or it will be the one-time task.
No, every time it will do. As he said, every time it will do. But on which part it will do? This is my question now. Again, if I'm removing that DDR4, on which part it will train? It have to train on the DDR4, correct? So whatever the RAM installed in it, so on that part it have to train it, correct? Now, so if I am replacing that with a DDR5, if my laptop is compatible, if my controller is compatible, then obviously my controller will train that on DDR5, correct? Before starting the laptop or the booting, whenever the booting it is happening. So that time it will train that DDR5, and then it will get ready for the further processes, further like operations, correct? That's what I am telling actually. Whenever you remove or whenever you replace something, so on that part it will do the training on it. Pankaj, am I right? Correct, right?
Yes, yes, sir. Yes, yes.
Okay. So anybody have any doubts in this?
Amit, what
Anybody
we
have any
understood
doubts in
is
this?
in DDR, different types are there. We DDR, LPDDR, GDDR, and HBM. So GDDR mainly used for graphics cards, and LPDDR mainly used for mobile phones, and HBM mainly used for high performance processors, high performance AI computing devices. So yeah, understood, Amit, at this point.
Okay. Okay. So otherwise, anybody have any questions? Abhishek, Ashutosh, Neeraj, Pradeep, Iqbal, Pankaj, Kuldeep, Manjunath, Utsav, Mokshita, Shravya, Bhaskar, Dhuvan, Pratibha, Premchand, Devansh, Pankaj, Mahesh, Ajay, Narsimha Reddy, Nikila. If you don't have any queries, so just put it in the chat no, so that I can get to know. Yes, everyone. Okay. 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 Hmm. Okay. So the next part I want to explain you is, our course motive. Okay. So basically our course motive is nothing but, so we are targeting every one which who don't have, if you don't have any knowledge of the DDR, it's okay. You can attend our course. You can attend our course and you will gain a lot of knowledge from this. And moreover, we are not going to target basic overviews of the DDRs. We are going very in depth of the DDRs. In each topic, we are going in depth of the DDRs, which is required, and we are not going overview of the DDRs. Not even a single percent, not even a single topic we are going overview. In every topic, we are going in depth of the DDRs, and every topic we are going in depth, and we are going to explain that DDR concepts. I'll tell you now what are those concepts. Okay, and next part. This DDR courses structured in a way which is adhering the industry standards. Okay, we successfully completed with this course only. We successfully completed the one batch, and this is our second batch. Successfully, we are stepping into our second batch. Okay, we actually we did a lot of concepts, and we are again in this second batch. We are adding a new feature, new concepts to it. Okay, and again we are going to take some more concepts at like enhanced concepts from the previous batch, and then we are adding it, the corrections we are adding it, and then we are making this batch. Okay, this is industry, whatever the industry is working, whatever the industry it is going on. Since I'm also working in a product based company, and I'm also working in the DDR project only, so I have a thorough knowledge of this DDR. Okay, I have worked on the 5 years on the DDR itself, and that is the reason I'm telling these kind of things. Okay. Also, Chandan, you can see Chandan is all working. Chandan is working on a one product based company, and he's also working on a DDR for 6 years. Okay. Okay. We both are the mentors for this course. Okay. We are going to take care of this course. Okay, until the end of this course. Okay. Now, if I go to the DDR like a course plan. So the course plan something is like something like this. Okay, this will take a 2.5 months of duration. Okay, including the part one and part two, and the cohort will be optional for this. Cohort will be optional, and after this 2.5 months, so the cohort part will be completing. What is this cohort part? We will look into further. Okay, and again, I'm saying that this course is very industry standard, and whatever the required for the industry to work on the DDS, that is what included in this course. Okay, and we are divided that course into two parts. Basically, it's two parts. Basically, we can say three parts, but I can say it is a two part only. So the part one is DDR3 and DDR4 theory, which is going to take 1 month, which is going to take 1 month, and the part two is nothing but the DDR3 protocol verification with the DDR3 controller behavioral model. So basically, we are going to write a controller subsystem. I'll explain you with the architecture of this part. Okay. So we are going to write a DDR controller behavioral model of this, and using that, we are going to generate a DDR protocols. So the commands basically. So the commands, and we are going to use a DDR verification IP. Okay, which is a company's VIP only. We are not like a we take like we got it from a company. Okay, we are going to use that VIP and we are going to verify the DDR protocol along with the UEM environment, verification environment. Okay, and the next part is this is the cohort part. In this cohort part, whatever the behavioral model you written, whatever the behavioral model you written. So from this behavioral model, we are going in depth and we are going to study each and every blocks, IP blocks. This is the additional part I'm saying again. This is the additional part. After this 2.5 months, it will going to continue. Okay. Now this cohort part is nothing but everyone from the previous batch, from the future batch, from the your batch is going to contribute to this projects, and everyone are going to learn from this project. It is nothing like you are going to code. Yes, we are going to code that. We are going to code that. We are going to code that together, and we are going to explain it to everyone. Okay, this is like open source project. Okay, the 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 what you will get from this code, the cohort part, you will get a chance to work with others from your others from your company, others from your company. Okay, so you'll get that chance and you can work with the others. Okay, and you'll get a lot of knowledge who is also working on the DDRs again. So from the previous batch also, we had some of the people who are working on the DDRs, who are working on the HBMs, and they were taking the part in this code part, and they were coding in it. So small blocks, so small logics, the small debug is there. Okay, what is that debug? So they used to write that debug note and they used to send in the WhatsApp group. So these are the debugs we have to fix it like that. So those kind of the project we are going to work in this code part. But before that, you'll be going to get the full knowledge of the DDR using this. Okay, you'll get that once you get the DDR protocol knowledge. Yes, this is very easy. You know where to do what, then you can do it very thoroughly and very efficiently also. Okay, that is the reason we added this part. Okay, and if I come to the part one here, so in the part one, we are going to introduction of the and the fundamentals of the DRAMs. We are going to do the introduction and the fundamentals of the DRAMs and DDR3 and DDR4s. Okay, and also we have the DRAM architecture and evolution of the DRAMs. I said right. So the DDR1, DDR2, DDR3, DDR4, DDR5, we have how we have that, how the evolution happened, what are the features included in the DDR1, what is the differences between DDR1, 2, 3, 4, 5, like that. And again, next we have the ECC, error correcting code, ECC chips. So we are going to get the knowledge of the ECC chips. Don't worry about the ECC. So if I start to explain, this is a very big topic again. So just observe the keywords here. ECC is there. Then again, the DDR3 and DDR4 timing parameters. So there comes a part of speed bins. There comes a part of nomenclature of the DDRs. So according to the JDEC spec. So again, I forgot the part. So how we are going to focus this? How we are going to do these topics? What is the reference of mine? Am I going to refer some websites? No. I am going to refer. I am going to refer the
JDEC
JDEC
specs.
official specs. Official specs. Okay. Official JDEC specs I am going to refer and I am going to explain things. Not like I'm not going to refer any other websites and any other things. No, I'm then what is the use of mine, right? So that is the reason. Every reference what I'm going to take, that is going to taken from the JDEC specs. Every JDEC specs will be provided. Every JDEC specs will be provided. Okay, if I can show you in the from the previous batch, if I can show you from the previous batch, so I can show you that. So these kind of the So wait, here you can see. Here you can see. So JEDEC specs we have this JEDEC specs. See, JEDEC spec DDR3 JEDEC specification, DDR4 JEDEC specification, Micron DDR4. This is the vendor specific DDR specifications. Okay, IP specifications. This is the Micron DDR3 specification. Again, we have two more things. LPDDR specifications we have. This is the controller specification, SK Hynix from the SK Hynix. Okay, this is the SPD. If you know SPD, okay, you'll get to know that what is the SPD, and DFI interface is there. The DFI interface, everything will be explained. So everything related to everything, we have the specifications, standard specifications. We are going to follow that only, and you'll be getting this specifications along with the course itself. Got it? Got it? And next, what are the things? The DDR3 timings, addressing, and command structures, and those are also referred from the JEDEC specs itself. Okay, and the next one here is the comprehensive training program and the duration. Sorry, this one. So the memory hierarchy in the computers, how the memory is arranged, how the data is going to flow, how the SRAMs are arranged, how the DRAMs are arranged. Got it? How the DRAMs are arranged, how the SATA bus is working, how the PCI bus is going to work with this. Not in the in-depth of it. I'm just telling you how the data flows through the DRAMs, how the data flows through the SSDs, how the data flows through the SRAMs, like that. Okay, so the hierarchy of the memories inside the computers. Okay, different types of the memories in the computers. Okay, how the data flows in that, how the memory system architecture in the SoC. We are going to take one example of the SoC in the one class, and I'm going to explain you how the data flows in that, what are the arrangements in that. Okay, and the role of the DDR3 in the system memory architecture, what is the importance of that, like that. Okay, and now what is the differences between DDR1, DDR2, this kind of different DDR versions? We are going to compare it and we are going to explain it. Again, I am said as telling in the today's class, right? The DDR
Caller, please wait. I think, yeah, wait. I will inform them. Yeah. Hello.
Chandan, you want to say something, Chandan?
No, Amit. I think your screen is suddenly stopped. No, Amit. Yeah. Please proceed.
Okay. So Premchand is asking, are we going to use only SV, UVM to write the test cases, or we will use the C? Actually, Premchand, we are only going to use the SV and UVM test cases, not the C test cases, since we are not working on the SSC things or the any other UVM RAL things. For that purpose, we are going to use the SV and UVM test cases only, Premchand. Okay, I hope that is clear. Okay. So Mahesh is asking, will the DDR design be purely in the system Verilog, or would you be using some kind of IP along with the yes? So the DDR design, which is we are going to use, that is ready-made. The DDR design is ready-made. Because why I'm using that? So that's the main question. That's the main question. Why I'm using the ready-made? We are going to design the controller. I'm saying we are going to design the controller to produce that particular DDR protocol. But we used to have a one particular standard IP, which is we are going to use VIP. We are going to use that from a company which is a DDR. Okay, DDR3. We are going to use that VIP, and using that VIP, we are going to verify that protocol. Because at the end of the day, if you ask me, what is the proof, what are we are going to do, where is the proof that we are going to do that in a particular way? Like, how will you believe me? So that is the reason what I did is I took a standard of the DDR VIP, and we are going to design the controller for it, so that you can get to know the state machine in it. Okay,
So, sir,
so
it is a controller verification.
actually the protocol verification, you can say, not the controller verification. The controller verification parts in the next part.
Okay,
If you start that
in
cohort
the
part, right?
cohort part. Okay, sir.
Yes, in that cohort part, you can get the whole controller verification and the PHY verification also.
Okay, fire verification also.
Yes.
Sir, can you tell, sir, what we exactly learn here in the coding part?
Okay, in the coding part, you basically learn the DDR protocol, like how the protocol, how the DDR works.
So
From
sir,
the AXI to
we
how the DDR works.
so sir, we directly write test cases of DDR like
No, you
training
are going
part.
to write the test cases. No, you are going to write the test cases for the AXI, test cases using the AXI only.
Okay.
You're basically like verifying a subsystem. I'll tell
Okay.
you the with architecture. I'll tell you the with
Yes.
architecture
Yes.
in the next coming
Yeah.
slides.
Yes.
Okay, Mahesh, we have the DDR ready, but we will design the controller to interface. Yes, of course. Yes, absolutely. Mahesh, yeah, you understood it correct. Also, I saw AXI in the syllabus. So will we have the code? Yes. I'm going to explain that using the our architecture in this. So we have the architecture for it. Okay, I'm going to explain that. Once we complete that, you'll get all the answers for your questions. Mahesh. Okay. Okay. So the DRAM, the evolution of that DRAM and DRAM package types are there. If I can tell you, sodium is there. Okay, small device, so small, uh, like it is a kind of packaging which is used for laptops, kind of things. Okay. Similarly, we have a different kind of packagings of the DRAMs. Correct. So those kind of things we are going to discuss in this part. Okay. And if I come to the next, so there is a ECC part, which we are going to see the some ECC features. What is that ECC going to do and how it going to interact with our normal RAMs, normal RAM modules, and how it going to interact. Okay. So that is the theory part. And again, we are going to look for the internal architecture of the DRAM modules, how the bank is arranged, how the row and column addressing is there, what is the timing, critical timing parameters are there, what is the address mapping strategies are there in the DRAMs, and the calculations of the DRAM configurations, like that. Okay. And if I come to the next part, so the pin configuration, obviously, pin configuration and the mod registers are there. What is the number of, what is the types of mod registers are there? What is the features in that we are going to cover? How we are going to set that up, and how we are going to give the commands of the mod register to the DRAM along with the along with the uh, calibrations, along with some features attached to that moderator command, how we are going to issue to that DRAM module. So those kind of things we are going to discuss in this moderator. Okay. And the register configurations for the latency, burst length, and OTT settings. So these kind of the settings we are going to read from the SPD. For example, I'm saying, just don't to think too much about it. So we are going to read these kind of things from the SPD. So now where is SPD present? So these kind of questions you'll get. Okay. So don't worry about it. So these kind of things only we are going to discuss in that. Okay. Next, we have the clock management. So we have the different kind of clocks in this. So one is DLL lock loop, and one is PLL, phase lock loop. So we are going to look for the applications of it. Where is the use case of it in the DRAM? And next, we are going to look for the ODT, on-die termination signal integrity, for the signal integrity of the. Then we are going to discuss on which signals the ODT is going to apply, on which signals it is not going to apply. Those kind of things. Okay. And next, ZQ calibration is coming. What is the ZQ calibration? Where the where this part comes in the state machine? Okay. What is the features? Now the features comes auto refresh, self refresh mechanisms, and the refresh time intervals. Okay. Power saving techniques. What are the different kind of power savings algorithms we have in that? What is the different kind of power saving techniques we can manage in the different kind of DDR versions? Okay. And the DDR state machine. Once you understand all the above features, now we are going to look for the DDR state diagram. We have a in a JDX spec, we have a particular part in which we have a DDR state diagram in it. Looking at the state diagram, we are going to do one by one step. Okay. So similar kind we are going to follow in the DDR controller part also. To design that controller part, we are going to use that state machine, and we are going to design the controller part. Okay, state machine part. Okay, then the power up sequence, reset and initialization and power down states, and the DDR command truth table. We have the different commands in the DDR. Then how we are going to do that? We are going to refer the JDXPEC, and in that JDXPEC we have the particular truth table for that. For every command, we are going to use that. Then the command functionalities. What are the different commands are there? Those kind of things. Those kind of things. Okay. Okay, and this everything present inside this part, this catalog. So that is only present in our PPT also. Don't have to worry about it. If you are referring the catalog, so that is the same part present inside our PPT also. You don't have to worry about that. Okay, DDR. Next, we are going to do the DDR verification part. Okay, so this is the DDR3 protocol verification. Protocol verifications. Part one ends there. So the part two starts here. Part two starts here. So in this, what we are going to do? What we are going to do? We are going to set up a environment for that. I'll explain you this one using this. So you can see hope my screen is visible. Hope my screen is visible for everyone. Can anyone
Yes,
just
yes.
reply?
Yes, you can see.
Yes, screen is visible, right?
Yes, Amit, visible.
Yes, yes, it is visible.
Okay. See, in this part two, we are going to target the coding part. Which part we are going to design? So we are going to design the parts which are from this, from this. Okay. So whatever the left part is there, whatever the left part is there, we are going to design this. We are designing this. Okay. And this part, whatever you are seeing, DDR, DRAM, this is the VIP. This is the VIP verification IP. We are going to use it. We are going to use this. This is the standard one. This is the standard one. Why? Because we don't need the IPs now. We already have the IPs. We already have the IPs. You have to get the knowledge of the DDR protocol because in the see you are see the audience, like we need the people to understand the protocol. Whatever the commands you are going to issue, whatever the commands you are going to get back, whatever the data you are going to issue, how you are going to get the data back, those kind of things you need to understand here, not the designing of this way, not the designing of this IP. Because if I target the IPs or designing the VIPs or designing the IPs, that is not the, that is you are not going to learn that much. You are not going to learn that much. But if you are going to target the controller, then you are going to learn a lot. Why? Because you are also going to learn the AXI part here. You are also going to learn the AXI part here. Why? Because we have the three masters in it. We have the three masters in it. So one, I'm giving the example here. This is the PCI port. I'm taking this as a PCI port, not a PCI master. This is the DMA. Now in this case, so I'm taking it as a DMA port. So now this is the SPD configuration. So this is nothing but you can take it as a one AXI master one. Okay. Master. So I'll take it as a master one. I'll take it as a master two. I'll take it as a master three. So all are AXI masters. All are AXI masters. In this, I'm giving it as name as PCI, DMA port, and SPD configuration port. These are kind of the names we have given, but these all are AXI masters only. Now, from these AXI masters, we have a AXI slaves in this. AXI slaves in this. So from this AXI interconnect, we are going to give the data to the memory controller. Inside the memory controller, we have one block which is config registers. For this config registers, the data from the master 3 will going to write it to the config registers. From the config registers, we are going to extract the values. For example, some registers are there, some variables are there. For that variables, we have written the values from the config registers. Config registers. We are going to take that values from the config registers and we are going to use them. Understand? Understand? So in the first part, what happens? First part, what happens? Until here, we are going to design this as a one. Design this as a one. Okay. Design this as a one. Like we are going to design this part, this part, this part, which is controller, which is combinedly called as controller. We are going to design this controller and we are going to generate the commands for it. We are going to generate the commands for it. Now what happens? So you are going to generate the commands for it, which is required for the DRAM, and you are going to verify this commands. How we are going to verify this commands? We are going to follow the some scoreboard based verification, or the and the monitor, using the monitor and scoreboard based verification we are going to do on this. Now, how we are going to connect that? See, So this part we are going to write. This part we are going to write, correct? The DDR subsystem. This is the controller. This is the controller. We are going to write. So using this controller, we have set it up the AXI master VIP AXI interface is there and the sequence block is there. This is the UM setup we have done. This is the UM setup we have done, correct? This is the UM setup. Okay, using this UM setup, we are going to verify the protocol. How we are going to verify the protocol? So we are connected the one monitor here, and we have connected the one monitor from here. Okay, we are going to take the reference module as a controller here inside the scoreboard, and we are going to generate the exact same thing which is going from this and coming from this inside the scoreboard, taking the reference from this. Okay, then we are going to compare it in the scoreboard. This is the part we are going to follow in the coding part. Got it? Got it. And after this part, what happens? After this part, what happens? So after this part, we are going to design the this controller part. Again, I'm telling. So now, once we complete the part two, already you have sequence block, AXI masters, AXI interface, monitor, scoreboard, coverage, monitor 2, DDR interface, DRAM, VAP module. You already have that. Now, we just created one module right here in the part one. Now, in the cohort part, what happens? In the cohort part, we are going to design this DDR controller separately. We are going to design this PHY block separately. Then we are going to integrate. Then we are going to integrate. Then we are going to check once again the integration is correct or not. Then we are going to verify this controller. Then individually we are going to verify this controller. Then individually we are going to verify this PHY block. Then we are going to integrate. Then we are going to do the subsystem level verification. Got it. This comes in the part of the code.
So, sir, in part two, you will provide all these things, the DDI controller file.
Yes, yes, yes.
Okay, so it is already whatever you made it, the coded. You will provide us.
Yes, yes. Obviously, I'll be providing. So, for example, also I can show you. So already we have
And
the code.
sir, later part in part three or in cohort part, we will again develop the controller
Yeah,
thing.
yeah. We again go into the inner part of
Okay.
the controller subsystem. So in the previous one, we in the part two only we completed the controller part, right? So
Mm-hmm.
only one module we created.
Okay, sir.
Everything in the inside one module. So in
Okay.
the code part, what happens? So we are going to develop the DDR controller separately, PHY
Mm-hmm.
block separately, and verify them individually, and then integrate them and then verify the subsystem individually. Like this, it
Mm-hmm.
will happen. Understand?
Okay, sir.
Amit, it's look like more effort from students only, right? So part three is
So
full
yeah, this
effort.
yeah. So what happens here is that is let me show you. So this part is there, right? This part is there, right? Whatever the controller part I am going to design in the part, that is completely we will going to provide. We will going to provide. Okay, you don't have to write a single code in that. You don't have to write a single code from your side. But when it comes to the DDR controller, once we move into the code part, once we move into the code part, in this what happens? Everyone have to work on it. Work on it. Nothing like you have to learn it, correct? So once we complete this part two, you will be getting the knowledge of the protocol, how to drive the signals, how to get back the signals. So what is the part we have to verify? Everything we have to verify here. So that part you will be getting in the part two. After completing the part two, you will be understanding everything. Then what is our main part? We have to design the each controller part. Now you will be getting what is the features, or what is the features we have to implement inside the DDR controller. What is the features we have to implement inside the PHY block. Now what you have to do? Now you have to contribute small things to the DDR controller, small things to the PHY. That's not like you are going to code. You are only going to code. No, I'm also developing. I'm also developing. But how it happens? So everyone combining, it will going to prepare. We are going to prepare one IP, proper IP like that. Okay, that is nothing like you are only going to do the coding. No, no. We
In
already
part
have
one, it
that.
is
We
only
already have that
behavioral model.
particular. Sorry.
In part one, it is only behavioral model will provide, or
In the part two. In the part two.
in part one behavioral model, right? Or
In the
he will
part
provide.
two. Part two.
Okay.
In the part two, we are going to provide the behavioral model. Okay.
So,
So
So
you
sir,
can
part
see.
part
part
one is related to theory only, right?
So yeah, part one is related to theory only. Part two is related to this behavioral model. Then the part three is cohort part.
Part three
sir,
basically it look like a assignment only. Like majorly it's
Yes,
assignment
assignment.
only.
Yes, assignment
They
only.
need to work
Not a,
on this, then you will support them for if any difficulties like that. Correct, right? I
yes,
think
yes,
this
yes,
is last 15 days program.
yes, yes. See, already we have that code parts code ready here. So you can see the RTL the thing is ready and the TB is ready. Okay, AXI thing is there. Okay, inside the RTL code we have the AXI slave is there. Inside the AXI slave we have AXI slave 0 module and AXI slave here and AXI slave 1 module is ready. Okay, which is like a PCIe port. This is like a PCI port and this is like a config port. Okay, already we have the controller part. This is the controller part. Whatever I have prepared here, right? This is the controller part. And again, we have the PHY block. Inside this PHY block, again, we have a small blocks, which are PLL block. Here we have a PLL block. Here we have a training model. Training will particularly come inside my PHY block. Correct. So now I have the PHY blocks. Already the code is ready. The code is ready. What we have to do? We have to increment, implement it more. Implement it more. Add some more features. You have learned it. Then you have to do the more features in it. Correct. So now, if I can show you, this is the cohort part. Whatever the code I'm showing, this is the cohort part. If I can open and show you the this part. Sorry for that. Okay, so you can so here we have we have the here we have the code of the behavioral model. So the DAT package is there inside this. We have this one, and the burst is there. So this is the normal this one behavioral model of the controller. Using this only, we are going to verify our protocol. Okay, everything is ready now. Everything is ready. That is not like we are going to do it in a real time. No, everything is ready, and using that only, we are going to explain that code one by one, and you are going to do the same coding. You'll get the code, and you'll be running that code side by side in the daily classes. Got it?
sir, one question.
Mhm.
So here in this architecture, DRAM will work like a slave.
Yes.
And sir, we will do like how master will in like somewhat AXA environment, and then how master will communicate with the slave. That's what we will do here.
Yes. 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 How the translation will happen
Since
there
here we are mainly
from the.
verifying this IP, right? Memory controller subsystem IP we are verifying, right?
Yes.
Mhm.
Yes. Yes. Yes.
So here, Pankaj, what we are doing is industry side also. Why need of VAPs? We need to verify IP purpose, right? See here,
Yes.
slave side DRAM is there, master side AXA is there, but in between memory controller subsystem IP is there. Our final goal is we need to verify this IP is working correct or wrong. Once
Mhm.
this IP is verified, then this IP only we will dump inside our system on chip, right?
Mhm.
So our goal is either industry side also. Major goal is we need to verify the our controller IP is working correct or wrong by using AXA master VIP and DRAM slave VIP.
Yes. Yes. Sir. Yes.
So that's only our main goal. So here also we are major goal is simply we are not sending transaction to DRAM slave. Our main goal is we need to verify this memory controller subsystem. What is the memory controller subsystem task? It will convert AXA address to DRAM address, or it will control the frequencies by using clock
Yes.
mechanism,
Yes.
or
Yes.
it will control the timing parameters between activate, write, read. Those all properly working correct or wrong.
Okay, sir. Okay, sir. So, sir,
And for
like
two
yeah, frequencies differences will also there. Like AXA will work in different.
Correct. AXA
Okay.
is working at
yes, yes.
400 mega and
Yeah, yeah,
400 megahertz. Our DRAM is working at 1600 megahertz. Everything PLL block, DLL block will take care.
yeah. Okay, sir. Okay.
And to design this kind of behavioral models, you need to understand the working of this DRAM, how the internet things are happening, and you have to understand the JDEC spec. According to that only, you have to do the controller design. Correct?
Yes, yes, sir. Yes,
That
yes.
is the reason that is cover. We are going to cover in the part one. Got it? Okay. Uh, Anyone have any other queries?
Yeah. So in this case, our main goal is we need to verify our DUT. What DUT? Controller subsystem or memory subsystem DUT. We need to verify. That is our main goal for this. That's the DDR subsystem. So here, DDR controller, DDR5. This is the DDR subsystem. Because DRAM is not a digital device. DRAM is not a digital device. DRAM is mixed device. Mixed means it consists of both analog and digital components. So coming to, but our IPs are most of the majority things are digital only. Controllers are digital, right? As a verification engineer, what's our task is we need to verify this DUT is working correct or wrong. As a design engineer, what our task we need to design this memory controller subsystem. So this course majorly helpful to design and verification engineers. Design engineers also it will be helpful because coherent like last part we design engineers will get more exposure on design things. As a verification engineer we need to focus more on AX and DRAM side. Yeah, that is the thing. So part one is majorly theory part. Part two is full AXA VAP development, this DDR controller subsystem, behavioral modeling, and monitor, two monitors, scoreboard, coverage, and multiple test case development. See here, simply we wrote sequence block, but it will come multiple test case development. So those are test case developments present in part two. Correct. Part 3 is look like your effort will be 90%, support will be 10%. Part 3 is see our course majorly we plan for finally you people need to touch with industry way. Like for example, industry you need to learn, you need to work industry way like that. That time previous batch are some like in your group only who all are too much dedicated. I know in one batch everyone is not dedicated. I'm sure finally we get max 10 students for dedicated persons. Daily they are attending classes, daily they are doing works. For those people will get chance to explore more on DDR, so they will start developing more about. See, thing is, I we didn't say we will cover all features of DDR. That's not possible. If industry side 5 year, 6 year employees also they didn't cover all features of DDR. We will try like what we discussed here. Like finally we can able to send few of like commands and all multiple write and read transactions we can able to achieve. So some ZQ like what we mentioned theory wise, those all we can able to try, but all features we can't. But so then all features what after course we can able to support you people. You people try to do that. That is the main thing. Yeah. And also daily classes will be 8:30 p.m. to 10:30 p.m. So except Sunday everyday class will be there. So because daily classes they're not like we don't do any weekend batches first of all, because we are weekly 2 hour 4 hour that's not enough for us. So we are doing daily classes daily. We are doing currently EXA batch also going on, UVM RAL batch also going on, and advanced UVM RAL and DDR batch also going on. Next week PC also going on. See, our courses are very different compared to other training institutes, because most in this batch most of students are referred from previous batch students only. Most of I didn't take name. Most of students are referred from previous batch students only, and each batch we will allow 30 students only. Yeah, this and all okay, no issue. So that and all later on will come. So here like in these concepts, like who all are any doubts please ask. So coding wise, as I mentioned, DRAM VIP, no, we didn't touch about DRAM VIP. We took from industry standard. Why means if DRAM VIP also we only design, then how you people how we can, if try to assume DRAM VAP only, we only develop. If tomorrow someone will ask question, sir, how you believe you did correct way or wrong way, means how can we answer? That's not possible, right? That is the purpose DRAM VAP we took from standard DRAM VAP. We need to develop design code test AXI master with respect to that DRAM VAP. Then I can able to say after course, yeah, we are doing standard way because DRAM VAP we not design, we took from some other company like that, right? That is the purpose, sir. Why DRAM VAP didn't design means, but that's very easy task. We can able to design. But finally, if someone will ask, sir, how can you judge this industry standard means, that's we also need to tell some valid points, right? That is the purpose. And one thing I will tell, Amit, please stop recording. One thing I